right, so welcome back to part 2 of our NMR lecture that's talking about carbon NMR. We've already talked about what are the things to look for in the carbon NMR and sort of what's the theory behind that part, but now we're going to actually apply it to some problems. So let's look at that. All right, so let's talk about what kinds of problems we'll have for carbon NMR. Generally, we're either going to have multiple choice or you're going to use carbon NMR with something else like hydrogen NMR to figure stuff out. So you're never going to use it by itself to try to figure out what a structure is. So for right now, we're just going to focus on multiple choice since we don't know any hydrogen NMR. Okay, so let's do that. So here's the strategy that I want to use when I'm doing a multiple choice problem with carbon NMR. I'm going to first look at the shifts just to determine the possible functional groups. If I can do that, I might be able to eliminate some of the choices. So I want to do that first. So I'll do that first, looking at the handout, and then cross out anything that doesn't match. Then the next thing I'll do is count the number of peaks for the choices, not like that you see, okay? Just that way you can make sure you're looking for symmetry in your answers and you're not going to miss anything or have too many peaks. Does that make sense? Because again, we're working backwards here. Okay, then the last thing we're going to do is check the answer by labeling the molecule, making sure there's one peak for every carbon and that we don't have too many or we're not missing one. Now, sometimes you might have two choices that have the same functional group and number of peaks, so you'll just want to make sure that the peaks that you see match where they should be shift-wise. So that's like a good double check if you've got something that's really close. Okay, so let's try. All right, so let's look at this example. So the first thing we want to do is look at the possible functional groups. So we'll go to each peak and sort of look on the handout. So our first peak is here. So what functional group would that be that's right around 200? Right, it's going to be either a ketone or aldehyde just like we saw before. So I'll write that down. Okay, so then if I go further to the right, I have a couple of peaks down by 20, but those are just carbon-carbon bonds, so those aren't really special, so we're not going to worry about those for functional groups. I have a peak around 50, so that could be a carbon-oxygen, carbon-nitrogen, or it could be something next to a double bond O. So if I look at my choices, it could be either O or double bond O. So let's start using process of elimination. So if we look at our choices, we know that it can't be anything without a double bond O, so we're going to cross out all those choices first. So now that I have those crossed out, I know it's not going to be a CO. This is just going to be the other peak next to the double bond O. So then all I have to do is count the peaks on the choices. So I'm going to do that next. So if I look at choice A, how many peaks does that have? Right, it should only have 3, 1, 2, 3. This one here is 1 because it's got that symmetry, right? All right, and then that's going to be 3 peaks. And then how many does B have? Right, it's going to have 1, 2, 3, 4. That's the same. So that's going to be 4 peaks. So then if we look at our actual spectrum, how many does that have? It has 1, 2, there's actually 2 here. So if you look really closely here, it's thicker there. That's because there's 2 peaks there. Anytime there's something like that, I'll usually also make a note of it if there's 2 peaks that are so close it's hard to tell. Okay, so that's actually 2 peaks. So then we're going to have 4 peaks total. So then that matches B, right? Now, if I wanted to check it by labeling it, what I'm going to do is take the structure and then put letters on the peaks and see what matches. Okay, so I put letters on all the peaks, right? I put C and D on the end because there's 2 peaks there, and then I redrew my structure. So let's see if we can figure out where those peaks go. So I know that A is going to be where the double bond O is, so I'm going to put that by the carbon with the double bond O. So next is B. So B, it says it's actually the carbon next to the double bond, so I'm going to put that here. And then for C and D, they're so close together, it really doesn't matter. So you can put them either like this, C and D, or you can have them switched where it's D next to the B and then C. Either one of those is fine with me. I wouldn't count off for either. Okay? So that's our answer. And then all those peaks matched. We don't have any extra peaks. We don't have anything we missed. We got all the carbons. So we're done. So let's look at one more problem just to make sure we're starting to get the hang of it. All right, so this is problem 2. As you can see, this one has a scale that only goes up to around 80. That's just because the thing that I use to make spectra doesn't show you the full spectrum if there's not any peaks. It just sort of cuts it off. So that just means the highest peak is 80. It's not missing anything, okay? If we were to take it in the lab, it would go all the way up to 200 no matter what you do because that's just the way it's set up. But that's just the way my device works, okay? So this one we've got goes up to 80, we said. So what functional groups are around 80? So we'll look at our handout and find out. All right, so if I look at my handout, here's 80. As you can see, there's a triple bond. We can also go further up and then we get some other things. So if we go up here and up here, we can also get something next to a halogen, or we could get something next to oxygen. Those are the oxygen things that it could be. All right, so it's either going to be a triple bond or something next to an oxygen or something next to a halogen. So let's put CO because there's not any of those other choices. So that's what I'll put for now. All right, so now I'm going to look at 60. And 60 looks like it's pretty much the same choices. I could possibly have a nitrogen now, but again, there's no nitrogen in the choices, so I'm not really worried about that. It's right on the edge of just being a carbon-carbon bond, but it seems like it's a little bit further. So I'm going to say that's still definitely going to be a CO. All right, so then everything below 40 is just going to be carbon-carbon bonds, so that would be these peaks. And then we sort of know what our functional groups are, all right? So let's look at our choices and cancel some things out. So which choices are not possible based on the functional groups? Right, A and B, right? We don't have any double bond O's at all. There'd be a peak up at 200, and we know there's not. So it's got to be one of the three at the bottom. The OH versus not OH, just looking at it, that doesn't help us because we can't see H's. If this was a hydrogen NMR, that'd be helpful because we could look for the H. But here we can't really look for that. So basically, let's count the peaks next. All right, so on my choices, we'll look at C first. So how many peaks does C have? 1, 2, 3, 4. That's a carbon on the end. Don't forget line bond form. Okay, so that one's 4. And then let's see what D. 1, 2, 3, 4. Okay, that's also 4. And then this one is 1, 2, 3. And that one's just 3, right? Because that's the same. So that's going to be 3 peaks. All right, so 3, 4, or 4. So how many peaks do we have on our spectra? Let me make this handout go away. There we go. All right, so here there's not any like thick peaks that look thick, so we're just going to count them. So how many do we have? Just 4, right? So I know it's not E, so that's another one I can cancel out. So now I have to figure out based on the functional groups mixed with the number of peaks. So what's the difference between D and C? Right, so one of them has one CO bond, right? Because it has this and then a hydrogen. The other one has a carbon, oxygen, carbon. So this one actually has 2 carbons that are next to the oxygen. So that means that's probably going to better match our spectra, right? So that means our answer is going to be C. And then the last thing we'll do is just double check and draw the structure and see if the peaks match. So let's try to label it. So again, I'm just going to add letters to the peaks just in order. Redraw my structure, and then let's see what matches, all right? So we've got A and B, so those are both CO peaks. So again, if it's really close, I'm not going to make you like figure out which one's which. In this case, it's right enough to say that you know there's 2 CO bonds, so that's all you need to worry about. So I'm going to go ahead and label them. So I know that that's what they are, but if you for some reason wanted to switch those, that would also be okay. So if you had the green letters, that's also fine, okay? All right, so then we need to do C and D. So C and D, C is probably going to be closer to an electronegative atom, so that would be this carbon here, and then D is going to be at the very end. Does that make sense? So that concludes this talk. If you're in my class, of course, you can always ask me questions. Feel free. So just let me know how it's going. All right, thank you for watching and paying attention.